All right, this section 7.5, we are going to be solving radical equations. You can see my objective there. A big part of solving radical equations, as you can see in my objective, is to try to isolate the radical part of the equation on one side of the equation. And so I've given you that note again here in blue. That's a very important first step if necessary, and in this first problem it is necessary. We need to isolate the radical first on the left side of the equation. And to make that happen, I'm going to add 10 to both sides. I'm going to do the inverse of negative 10, which is adding 10, and that gives me the square root of 2x plus 1 is equal to 5. Okay, so I've accomplished this first step. I've isolated the radical, and now it's pretty simple to undo the square root of any expression. I raise it to the second power. So to undo the square root of 2x plus 1, I'm just going to raise that entire left side to the second. But we know in algebra, if you do something to one side, you must do it to the other side. So the result of raising the left side to the second power, it just gets rid of the radical. I'm left with 2x plus 1. The right side is going to be 25. And it's pretty simple from here. We just subtract 1 from both sides, divide by 2, and we get our answer. The directions are not, at least at this point, they don't tell me that I have to check anything. It's always a good idea. I'm not going to require it, but you can always know if you're right. Let's just do a quick mental check. If we did substitute 12 in for x, under the radical, do you see how we would get 25? 24 plus 1, and the square root of 25 is 5. And then when we do negative 10 plus 5, we get negative 5. So we know we have the correct solution. Okay? All right, so for number 2, the previous slide I told you to isolate the radical first, and you might be thinking, well, where's the radical? Well, in yesterday's lesson, we said that rational exponents could be written in radical form. Somebody raise your hand and tell me what I have circled in green. What would that look like in radical form? Dalton. Okay, so he said it would be the fifth root of the quantity x plus 1 to the third. So even though it's not written in radical form, we think of rational exponents the same way like we think of radicals. So the same concept is true. I need to isolate this binomial raised to the fraction power. So the way I undo multiplying by 3 is divide by 3. Okay, still trying to get x by itself or solve for x. So whenever I have an expression like this raised to a fraction, I can undo raising by a fraction by raising that to the inverse. Because what's the rule when I've got one power inside parentheses being raised to another power? What operation do I perform on these exponents? Multiplication. And what's the result of multiplying a number times its inverse? 1. So in essence, I've created x plus 1 to the first power, which is just another way of saying x plus 1. Now, before I move over to the right side, I got some people that will want to think multiply the left side by 5/3. We did not multiply the left side by 5/3. We raised it to the 5/3 power. Big difference. Okay, so that might be obvious to you, but for some reason, just experience tells me that I've got some people that want to think multiply. And I understand you are multiplying these exponents together, but you're not multiplying this side by 5/3. You're raising it to the 5/3 power. So if I did that to the left side, I must also do it to the right. So let's get the radical form. Avery, what is the radical form of 8 to the 5/3 power? Nice, the cube root of 8 to the 5th. And we talked yesterday how it's really pretty easy to do radicals like this. If you just break it up into two parts, just ignore the 5 exponent for a second. What's the cube root of 8? 2. Now just think of raising 2 to the 5th power, and you have 2 to the 5th? 32. So the cube root of 8 to the 5th really is just 32. And now it's pretty easy to get to our solution. Subtract 1 from both sides. Solution is 31. So the big takeaway here, the way to solve for x when we have a fraction exponent is just raise that side to the inverse of that exponent. All right. What about this example? I just pulled this from your homework page. You're going to be doing the evens on this page. So do I have a volunteer to help us out? How would we go about solving for x here? Adam.
So you raise the left side to its inverse, which is 3/2.
Very good.
And then you do the same to the right side.
All right.
And
okay, so in essence, if you want to think of it this way, these exponents cancel each other out, or they create the number 1. So I'm left with x plus 5 on the left side. Now I want you to pay close attention to what I'm about to say, because here is a very commonly made mistake. And I want you to just be aware, be on the lookout for this situation. Mackenzie, what is the radical form of 4 to the 3/2 power? Very good. She said the square root of 4 to the 3rd. All right. Now this did not come into play in the previous problem because we ended up doing a cube root. But whenever you end up doing an even numbered root on both sides, like we have here, this is a square root. It would also be true for a 4th root, 6th root, 8th root. You get the idea. Anytime that this root is an even number, when you're solving an equation, you must include plus minus. So what commonly happens here is people will get one of the answers, but they'll miss half of the credit on the problem because they only gave me one answer when there should be 2. So please be on the lookout for when you have an even root. You're solving for x in an equation. This is just for equations, and you end up taking an even root on both sides of an equation. Got to include plus minus. So we have x plus 5 is plus minus 8. Everybody see that? Square root of 64. So I'm going to get 2 answers. Just basically, it's like solving 2 different equations. X plus 5 is positive 8, and x plus 5 is negative 8. So my answers are going to be positive 3 and negative 13. And just read your instructions. If they don't say anything about checking your solution, then you don't have to do that. I'm going to leave it up to you. If you want to make sure it's right, it's a good idea to check it, but it's not something that I'm going to require. I'm not going to look at it. I'm just going to trust you to check it if you want to. Now, the directions change. Now you don't have a choice. The directions are going to tell you to check for extraneous solutions. What is, we've looked at this in the past, what do we mean by an extraneous solution? Thomas.
It's a solution that doesn't work when you plug it in.
Exactly right. We solved the equation, we got a possible solution, but when we put it to the test, we checked it, it actually doesn't work. So it's kind of like a fake solution. So when we get down to the end, in this case, we're going to have to actually make sure that our solutions actually work, and this will be part of showing your work on the homework. All right, so give me a first step here. Zan, what would you do first?
You would add to this.
Good call. He said add 2x to both sides. Isolate the radical. All right, and now what? Lauren? Well, it's already been it already is a square root, so maybe you mean this. Okay, yeah, you're going to square both sides. And here's another just little, I see this occasionally. When you square the monomial 2x, you should get 4x squared. Be careful there. And on the left side, you get 11x plus 3. Now, this is kind of exciting. We haven't seen these in a while. We haven't seen these since chapter 5. I see x squared. We're about to have to solve a quadratic equation. You don't look too excited. You don't share my excitement.
I am wrong. Yes.
Okay.
Wow.
Well, to solve a quadratic equation, we need to make it equal to 0. It's in standard form, equal to 0, and I've got 3 choices to solve a quadratic. Give me one of them. Our old friend, the quadratic formula. Okay, what else? Completing the square. All right. Maybe. What else? Not always, but sometimes. What else? We use the box method to do this. Factoring. So we got 3 possibilities. And the good news for you is, in this particular lesson, all of these, when you end up solving a quadratic, they all factor. So that's nice. So let's factor it. I'm going to go to new screen. What is that? Is it minus 11x minus 3? Okay. Factoring it as 2 linear binomials. Can you do that without the box method? Is it easy enough to do without the box method, or do you want to use the box method?
This works for me.
Let's run through the box method. It's always fun to do. 4x squared, negative 3. Multiply those together. What do you get? Okay, now we just have to figure out what are the factors of negative 12x squared that add up to negative 11x. Looks like negative 12x times 1x. And we'll just put those in the other squares. Find our GCFs. 4x, 1, x, negative 3. There's our factoring. 4x plus 1, x minus 3. Now, I haven't solved anything yet. The great thing about factoring is it just makes it easy to solve. So what are my solutions? There should be 2 of them. What are the numbers that make each of these binomials equal to 0? Thomas?
Negative 1/4 and 3.
All right, negative 1/4. And if you're not sure how he got that, you could just let this binomial equal 0 and solve for x. 4x plus 1 equals 0. Subtract 1, divide by 4. You get negative 1/4. This one should be pretty obvious, and he already told us that should be positive 3. All right? Now, the directions told us to check for extraneous solutions, so that's exactly what we have to do. So the book problem is where I go. You see the blue, that's what's given in the text, and that's where I'm going to go to check to see if these are actually good solutions. So let's start with the easy one. Start with 3. If I let these 2 x's become 3, does the left side equal 0? Let's see. 11 times 3, 33 plus 3, square root of 36, 6 minus 2 times 3. Does that check? All right, so 3 is not extraneous. What about negative 1/4? What is 11 times negative 1/4? Negative 11/4. And what is 3 as a fraction using fourths? 12/4. Minus 2 times negative 1/4 is,
Or I guess we add the minus.
so negative 1/2?
Yeah.
Okay. Everybody with me? So, does the left side equal 0? Under the radical, we have 1/4. What's the square root of 1/4? 1/2. All right, so this really is 1/2 minus negative 1/2. That doesn't equal 0. That equals 1. Therefore, we're going to label x as negative 1/4 as an extraneous solution. Okay, any questions? No questions? Yeah.
Is this going to be a major part of our, I guess, not just our homework, but further on down the line? On tests and such?
It's going to appear on your test. I don't know about a major part. I mean, there'll be 1 or 2 problems. And this is about half of your homework assignment tonight. First half looks more like these types of problems, and then the second half you're going to run into some quadratics. So let's do another one that's going to become a quadratic equation. So Anna, what would you do first? Add 5 to both sides. Okay, let's see. Andy, what would you do next? To the second? Okay. So actually both sides are going to be raised to the second power. Whatever you do to one side, you have to do to both. Very good. Now, be careful here. What I'm about to say is not right, but I see it a lot. Some people want to try to square a binomial like this and say that it's x squared plus 25. It's not right, is it? You could use FOIL. Do you remember the little 3-step mental math process I showed you? Square the first term.
Square first.
First times second times 2. First times second, 5 times x, and then just double that. And then square the last term. Hopefully after we've studied the Pascal's triangle, you now know that you should never square a binomial and end up with 2 terms. Why? What do we learn with the triangle? Yes?
If it has exponent of 2, then we simplify it out, the terms will be 3.
Yes, so in general, the number of terms that you get when you expand a binomial should be 1 more than the exponent. So hopefully that'll keep people from making this common mistake of squaring this and saying it's x squared plus 25. That can't be true. All right, so we're going to end up with another quadratic. This one's going to be quite a bit easier. Everybody see how I got there? When you get a quadratic, you need to make it equal 0. Let's see, Eli, can you help me factor this quadratic? It has 2 linear binomials.
X plus 4, x plus 3.
Nice. So our solutions are x is negative 4, x is negative 3. Now for sake of time, and because I think you should be able to check these, you can trust me that both of these work. We do not have any extraneous solutions in this particular problem. All right. Let's run through this one real fast. Virginia, what would you do here? which is, okay, so you're going to raise the left side to the second, and what about the right? Same thing. All right, very good. This is just too easy. What's the result, Jessica? Yeah, that's like a algebra 1 equation. 3x is 3, x is 1. Now, we're not going to take the time to do it, but what should I do now? I guess we could do it. We can do it mentally. Check for extraneous solutions, go back to the blue, and you don't have to tell me what the square root of 13 is, but can you see that the left is going to be the square root of 13 if I let x be 1? And that's also going to be true on the right, square root of 13. So left side equals right side. Good answer. Okay. Last one, and then we're done. In cases like this, where I've actually got two radicals in the same equation, I need to put them in opposite sides of the equation. I need to let them be on opposite sides. Because the goal is to raise both sides of the equation to the same power. But this is a little different because I've got two different powers. So I've got to choose the number that I could raise both sides to, and after I'm finished, I will not have any fraction exponents. Okay, so what is that number, Dalton? Okay, he's exactly right. Do you see why if I raise both sides to the fourth, that gets rid of fraction exponents in both cases? So that's the move I need to make. If I had raised both sides to the second, yeah, that wouldn't have removed the fraction on this side. So on the left side, I get x plus 5 squared. On the right side, I get 5 minus 2x. We've already done this. We've squared x plus 5 already, so you remember what that is? Yep. Set it equal to 0. What's the factoring here? Let's see. Blake, how do you factor as two linear binomials? Are there factors of 20 that add up to 12? What about 10 and 2? 10 times 2 is 20, 10 plus 2 is 12. So what are our solutions? Very good. And now we need to check for extraneous solutions. And we don't have time to do that, so unless maybe you can do it real fast. It looks like negative 10 is extraneous. And our only good answer of these two is x equals negative 2. Okay? Hopefully you have enough. I think there's a video out there, but it's in Educreation's format. But it's out there that where some of these I think have already been worked. Here's your homework for Tuesday. Hope you enjoy your day off Monday. And email me if you have any questions this weekend as you work on this.